Welcome back to the CXC tutorial. Today we are going to look at problems in geometry, in particular those involving circle theorem. This is a relatively easy topic, and even if you're not good at math, you may be able to pick up marks very quickly and easily, because all that is required of you is that you remember a few rules. Here are a couple of them I've listed here. First one is, if you recognize anything to do with parallel lines, then you can always apply the theory of alternate angles. That's a quick clue. Another clue would be your isosceles triangles. In that case, you know the base angles are equal, so you can move quickly towards getting the other angle. Then a very important point to note is whether or not your circle has one or two tangents, and we will look at exactly how we treat each case. Then we might want to look out for a cyclic quadrilateral, and critically there are some theories governing cyclic quadrilaterals. For example, opposite angles are supplementary, etc. You might find that you need to apply the theory which talks about angles at the center being twice the angle at the circumference. Angles in a semicircle is equal to 90 degrees. We have angles in the same segment are equal, and of course an important one, angle between the radius and a tangent is equal to 90 degrees. Okay, let us apply some of the theories we talked about earlier to this particular problem. This problem is asking us to find angle PTS, which is this angle identified here at the circumference, and it's also asking us to find angle RPQ, which is shown as well. Now the first thing we want to do is to, like I always say, is to look out for clues. The diagram is giving us a lot of clues. The first one is that if you notice line OS and PR, they are parallel. So we'll immediately want to apply the theory of intersecting lines, which says that the alternate angles will be equal. So angle SPR is going to be equal to angle OSP, as shown here, both being equal to 26 degrees. We move immediately to also recognizing that what we have here is a case where triangle POS is an isosceles triangle. I've identified here this in blue for emphasis, which means that the two base angles will be equal to 26 degrees as shown. So we will highlight them here. Notice the two sides which are equal, both OS and OP is the radius of that circle, so they are equal, which is why we have an isosceles triangle. So we identify the other base angle of 26 degrees, and by simply recognizing that the angles in a triangle is equal to 180 degrees, we get angle O as being the angle at the center, which is equal to 128 degrees. Of course, we can immediately apply our theory, which says that the angle at the center is twice that of the circumference. So the angle we are trying to find, angle PTS, is going to be 1/2 of angle O, which is 1/2 of 128, or 64 degrees. So we have found the first angle has been equal to 64 degrees. Now we go ahead to find the other angle, RPQ. To do this, we simply recognize that the angle, because we have one tangent in this problem, the angle between the radius OP and the tangent PQ is equal to 90 degrees. It's a right angle. So for this right angle, we notice that it is actually divided into three parts: 26 degrees for angle OPS. We have another 26 degrees for SPR, and the remaining angle, which is RPQ, the one we're trying to find, is simply the angle which adds to give us the complete 90 degrees. So we have that angle be equal to 38 degrees, as 38 degrees plus 26 plus 26 is equal to 90 degrees. So those angles are complementary. This is pretty much all that is required for problems such as these. Like I said, they're pretty straightforward once you recognize a few clues, and Next time we will begin the process in the same way, where we first recognize that there are clues out there for us in solving these problems, and we simply apply a few theorems and we should have an easy solution. Okay, see you next time.